Hello all and welcome. My name is Jesse Ricks. I am a teacher in the UK and this video is about memory. Okay, so the psychology of memory. If you study if you study psychology at A level, this is going to be a topic you do very early on in A level, and one of the first things that you look at are these three things. So you look at coding, capacity, and duration. Um, and we're going to be talking about what those are and the studies that you look at in A-level psychology surrounding those things. So the things you need to know for your qualification. If you're doing one, if you're learning this for fun, and then it's a bit of fun, here's some cool studies for you to learn. Okay, so let's get started. So it's kind of one of the first things you do on the memory topic. And one thing you're going to be considering, I guess, is how good your memory is. When I usually teach this in a classroom, there is plenty of interactive opportunities for students to get involved and do this and test their memory and see, where they're at and what these studies are and do them for themselves. But some of the other questions: can you hold a lot in your memory? So that's capacity, and then do memories last forever? So that's duration. We're going to be looking at those and answering those by the end of this quick video. So the first thing, let's talk about what coding is. So coding, the definition, the format in which information is stored. So this is either semantic, acoustic, or visual. There are other types of encoding, but they're the ones that we'll be looking at today. So semantic, acoustic, or visual. Visual encoding, so when information is in the environment, it has to go in and it gets processed. It gets processed in different ways. So if you hear information, like you're hearing information now, that is acoustic information, it's sound, okay? And that's going in, that's being processed by your ears and the complexity that is your ears. And then it's being processed, converted into electrical signals, and it goes to the relevant parts of your brain, okay? Visual information, the same, gets processed differently. It goes across different hemispheres and gets processed again by different parts of the brain. And then semantic information, semantic is to do with the meaning of words, okay? So if we talk about semantics in linguistics, semantics is the meaning that words have, and that'll be important in a second to know. Okay, so the complexity of the world gets processed, input, encoded in a different way. Okay, so that's all coding is, or encoding, as you might see it. Okay, so the first thing you have to learn in A-level psychology is this study by Alan Badley. He is one of the pioneers in memory, especially working memory, which you'll see. Now, let's talk about the study. So, Badley gave different word lists to 4 groups of participants to remember, and what they had to do with these word lists is they just had to recall them in the correct order. Okay, so they're just showing these different word lists, and then they just had to recall them in the correct order. That's it. These are the different word lists. These are the 4 different groups. So, group 1. Were given words that was acoustically similar. That means they sounded similar. So the examples on there: cat, cab, can. They all have a similar sounding, acoustically similar sounding words, right, in that group. Group 2 were acoustically dissimilar, so the opposite. So the examples are on there: pit, few, cow. Although there is some kind of overlap, but they're dissimilar, more dissimilar than the group 1 words. Okay. Group 3, semantically similar words. So again, I've just said that semantic words, semantics is to do with the meaning of words. So if they're semantically similar, then the words mean similar things. So great, big, large, these are the examples, and they mean similar things, right? And then group 4, as you guessed, is the opposite, is semantically dissimilar words. So words that just aren't related in meaning. Okay, so good, huge, hot, they have no meaning whatsoever in common with one another. Okay, so you've got these 4 separate groups. That's it. That's the first thing that you need to know in this study. Going on, so when doing this immediately, when trying to recall these words immediately, so that is what's called short-term memory. Okay, I've in these PowerPoints I've narrowed it down to the acronym STM for short-term memory and LTM for long-term memory. So when recalling the words immediately from those lists, okay, short-term memory. They did worse in acoustically similar sounding words. So words that sounded similar, okay? They did worse. When recalling after about 20 minutes, which is long-term memory, they did worse with the semantically similar words. So the words had similar meanings, okay? Large, great, huge, yeah? Now, in your textbook, it will then say, or then proceed to say in one sentence, it will say the findings suggest that information is coded acoustically in short-term memory and coded semantically in long-term memory. Now, the question I always get by students is, wait a minute, okay, wait. You just said that when recalling immediately, so short-term memory, they did worse at acoustically similar words. So how can then short-term memory be coded acoustically? Okay. There's a lot of different answers, but one of the answers is that let's say it's true. Okay, let's say we do take information in short-term memory. We have a preference for taking in information acoustically. Okay, by hearing it, like you're doing now. You're doing a fantastic job. You're hearing all these words, and the complexity that your brain is doing right now is taking on all these words and meanings, and it's converting them just like that. Okay, and it's doing a fantastic job. Let's say that's true. Okay, so if it is coded acoustically, what happens when you have to remember a list of words that are acoustically similar? Okay, that all sound similar. Well, your system that is in charge of dealing with that will get confused, overwhelmed, very easily. It's short-term information. It's trying to take information quickly, and if it's all similar, it all gets jumbled up. Not to mention, it just has to deal with it itself when it's something completely different. Okay, when they're dissimilar, your brain will have to look to other systems, and it will have help from other systems to help it out. Okay, so the cognitive resources would be shared. That's the only way I can really put it, cognitive resources, because parts of your brain are involved in different jobs. Okay, so the more differentiated things are, the more it can kind of spread out the responsibilities. Okay, and that the cognitive resources, right, that you've got going on, that they get spread out. When it all has to be dealt with in one or two systems of the brain, and then it can be overwhelmed quite easily. Okay, so this is where it comes into. I'm sure you've heard of like cognitive overload. Okay, this is what happens is when one or two areas or systems of the brain get overwhelmed with the same type and the same kind of information. Okay, so the findings suggest that coded acoustically in short-term memory, you're doing a fantastic job right now. You're remembering the things I'm saying in your short-term memory. Okay, you're doing a great job. And in long-term memory, we tend to understand meaning. Now that's very important if you are a student, or if you're learning anything, if you're a lifelong student, as the cheesy line. And then the meaning of the thing is what's important. Okay, that's very important. When you're studying, if you want to remember something for your long term, when you study, you need to have it make or be meaningful to you. Okay, so whatever that is, I mean, the things that you remember could be rude, could be silly, could be whatever they are, but as long as they're meaningful, then that is what is important. Okay, so that was coding, and if you are an A-level student listening to this, then you will need to know those studies and those findings and those results off by heart, because you can get a question on it, and you do get the marks from saying the methods, the results, conclusion. Capacity. So your memory has capacity, and that is the amount of information that it can hold. Okay. And one study you have to learn about A-level is this study, the digit span study by Joseph Jacobs. So this is what the digit span study is. Let's say I out loud, I say to you 4 numbers, okay, and I just want you to repeat them back to me in order, verbally back to me. Okay, so if I say 7, 3, 6, 4, you don't see them written down, but put them on the screen. 7, 3, 6, 4. And then you would say back to me 7, 3, 6, 4. Now, if what the digit span test is it's giving someone 4 digits and then saying them out loud to them and getting them to repeat them out loud. And then you add on an extra digit, and then you add on an extra digit, and you do that until you see where their limit is. Okay, so if I say 7, 3, 6, 4, I can't remember what the next number was that I put. 1, 73641, but I don't have it on the screen there. 73641, and you say 73641. 7364119, and you say 7364119, and then you keep going, and then until the point in which you fail to accurately, in order, recall the numbers, and you can keep going. 736419702, and so on. Okay. Now the question there, so that's the digit span test, and again, if you're a student, you'll have to know that. You'll have to know that, you know, you take 4 numbers, you read them out loud to a participant, and then you add a number on every time until they can no longer accurately recall in order the digits. So the question then is, how many numbers do you think people can recall? How many do you think people on average can recall that number at the bottom there when it's just said out loud to them? Do you think that's the case or not? Okay. And then this is where in class as a teacher I would get students to do it themselves. I really would. So I'll say, how many numbers can you recall? Try it yourself, right? Get on a piece of paper, write them down to the person next to you. See how many you can do. So if you want to try this for yourself, if you're in a house, your parents, siblings, whatever, give it a go. But the answer is the mean span for digits. This is what Jacobs found. The mean span for digits was about 9.3. Okay, so that's numbers. Okay, 9.3. How many did I put on this previous slide? 3. So I did put 9. Okay, 9 digits. 9.3. However, the mean span for letters was 7.3. Okay, so it's a bit different. So if I did the same thing, but instead of giving you numbers, I give you letters, could you recall them as easily? Okay, because in our day-to-day life, we use numbers quite a lot. Do you think it would be the same for letters? Now, on top of that, we're talking about capacity, right? We're talking about how much your memory can hold. So let's talk about chunking. You've probably all heard of chunking. It's probably come up before. I remember it came up in my GCSE psychology classes. But our recall in short-term memory, we say is between 5 and 9 items. Okay, so we say 7 on average. You can say either one of those, but our recall in short-term memory is about 5 and 9 items. But then that leads you to ask the question, what is an item? What counts as an item? Like, is it a number, a letter? What about a word? Is that the same? Because that consists of many letters. Or, you know, what is an item? Well, that's where chunking comes in handy, because you can take things and we can chunk them into items. We can take them into chunks. Okay, so it's not like a single number is an item, because if we take I tell you someone just had their 21st birthday, 21 is a number. It consists of 2 digits, but you'll remember the number 21. That's chunked. Okay, remember the number 21 in your postcode, wherever you live in the world. If it's D12, Ali67, like wherever you live, that those 4 digits there, digits and letters, that is a chunk. Okay, that's a recognizable chunk of information. Okay, an item of information. Okay, this is fascinating. This is absolutely fascinating, because chunking information into items is what happens all over the world in many different areas of life. So I've put some on there. I've said postcodes, right? They're chunked into a 4 and a 3, because we've said people can't. On the lower end, it's 5 items. People can't remember 5 items in their short-term memory. So when you've got something like a postcode, you put it into a 4, because it's less than 5, and a 3. Like things in 4s and 3s and 2s are a lot easier to remember. And if you have those chunks, then that's easy as well. Same with phone numbers. We chunk up phone numbers quite easy, you know. So 0800, you know, that's a lot of digits, but 0800, 01530, whatever. It's just 022, isn't it, in London? But whatever the phone numbers are, we chunk the sections down, and we feed them to people in sections as well. Da 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 da. Right? And license plates are the same. They're separated. There's gaps between them. They have chunks in them as well. There's just too many areas in life where we chunk information to make it easier and more palatable. Okay. This is where I go off and I talk about memory championships. Usually, because when I was younger, I was absolutely fascinated by memory, and I bought a book from a local bookshop by Joshua Four called Moonwalking with Einstein. I'm sure it's probably behind me somewhere. in which he got lost into the world of memory championships and realized there was a whole thing and wanted to, look into can people have better memories? And what he found is that there are tactics and ways in which people can remember large amounts of random things very easily. There's tactics and ways that you can do that, even if you just have an average memory, because people do, memories are overall the same, largely the same. It's just how you apply learning things into these things. So if you want to get lost down a rabbit hole, I'm not going to do it now in this video, but you can go look at World Memory Championships. You can read that book by Joshua Foer, Moonwalking with Einstein, and Darren Brown did a book, was it Tricks of the Mind, where he had a section in that book where, was it that book? Where he had a section in that book where he talked about how to do some of these things, how to do some of these feats of memory to remember things. Because in the World Memory Championships, one thing they do, for example, is they remember two decks of cards, all shuffled into each other, and then distributed randomly, right? Because they're all shuffled up, and it's two decks of cards, okay? And then the participant has to remember the not only the number but the suit as well. And people can do this; they can remember all of that really easily in a very short amount of time. So if you want to get lost, there's some information for you there to get lost down a rabbit hole of memory stuff, just because it's exciting for me. The last thing then is duration. So duration is the length of time information can be held in memory. And we're going to look at two studies here, because this is what's on your A-level spec most likely. If you do an AQA, it's short-term memory and long-term memory. Okay? Short-term memory and long-term memory studies. So let's look at the first study that's short-term memory. This is by Peterson and Peterson. And you may have seen this before if you did GCSE psychology. But this is what it is, essentially. This is what the study is. So 24 students. They did 8 trials each of this study. Each trial, students were given a trigram of consonants. So like the letters Y, G, M, for example, right? It's a trigram. There's 3 of them. Yep, and they were given that to remember. They were then given a 3-digit number, so the one I randomly put, 718, that they had to count backwards from until they were told to stop. Okay, so if I, again, this is where I'd do this in the classroom as well. I'd give you, well, you'd give each other letters, participants, give each other letters, and then a number, and you've got to count backwards until told to stop. Now, when they were told to stop weren't random, but they were told this to prevent any rehearsal, so you can't go YGM, and you can't make up a little acronym. You get me. Oh, there you go. There's an acronym. You can't take your time to do that kind of stuff. Okay, it's preventing this rehearsal. But the time in which they counted backwards from weren't random. This was the thing they tested, so they did it for 3 seconds, 6, 9, 12, 15, 18 seconds, all the way up to 18 seconds. Okay. Where they got them to count back from 3 digits. If you've never tried counting back from a 3-digit number and then give it a go, it's even worse if you have to count it back in multiples, right? So maybe count it back in 3s. So going 718, 715, 712, really takes it out of you if you do it for a prolonged period of time, and you do, well, do you think you end up forgetting? The thing you're supposed to remember previous? Well, let's have a look at the findings and results. So what did they find? After 3 seconds, the recall was about 80%. So even for some people, they couldn't remember 3 consonants after 3 seconds. The recall was 80%. But that's huge. That's large, right? That's great. But after 18 seconds, after the maximum amount of time, the recall dropped to a staggering only 3%. Okay, it's a huge drop just after that short period of time. Okay, so what does this tell us? So short-term memory duration, this is what Peterson and Peterson concluded. Short-term memory duration may be up to 18 seconds unless we rehearse the information. That's very important, hence why I've put it in green and made it bold. We can have short-term memory up to 18 seconds unless we rehearse the information. Okay, so that's that study. Yeah. Again, if you're in A-level, you've got to remember how they set out that study. The 24 students, trigrams, 3-digit numbers count backwards between 3 and 18 seconds. Okay, to prevent rehearsal. Rehearsal is the important part of that. And these are the results. The last study then, Barak et al. 1975, is our long-term memory study. Again, still remembering that we're talking about duration. So I wonder if you guessed from the photos what the study's about, but it's a study on yearbook photos. Okay, so they took 392 American participants. These were the ages between 17 and 74. I think that's quite useful to know, hence because it's about yearbooks. So 2 ways to test their recall from school yearbooks. With this, they got to test participants with photo recognition, 50 photos. They get 50 photos, in a kind of a lineup, and do you recognize this photo? Who is this? And not all of the 50 photos were of people from, that they went to school with. um, because they don't want to be like, yeah, maybe I recognize that person, I don't know, but when they really didn't. And then lastly was a free recall of just their names. Like, do you remember the name of this? Do you remember the names of anyone you went to school with? I mean, you could do this yourself right now. Do you remember the people? Do you remember the names of everyone that you went to school with? I sure as hell don't, but as soon as someone says someone's name, I go, oh, that's familiar. And I'm like, yeah, and that's like a lost memory. But those are the 2 ways: photo recognition, visual, and free name recall. Okay, saying names out loud. Now it was long-term memory because obviously these people are at different ages. So some of them have only just recently left college, and some of them have been left college for a long, long time. Now, what do you think the results were for the photo recognition? Do you think people in large can recognize pictures of people's faces? Do you think you could? Do you think you could recognize people's faces that you went to school with, especially if you're an older person watching this? Well, within 15 years of graduation, people were 90% accurate. They could recognize photos. They'd be like, yeah, I know who this is. This is Susie, whatever, from, 15 years of graduation, it was still 90% accurate, which is insane. And then after 48 years, it dropped to about 70% accuracy. But again, that's still huge. After 48 years, still remembering facial recognition of the people that you went to college with or school. That's insane. Now, do you think free recall was better or worse? So that was photo recognition. Do you think remembering people's names off the top of your head is going to be better or worse? Okay. Obviously, the answer is it's worse. For 15 years, again, that was 60%. And 48 years, again, that dropped to 30%. Okay, so the percentages were less, but they're still huge. That's still huge. For free recall, like no cues, no clues, nothing to jot your memory. That's still a large percentage, even after 15 years, even after 48 years. A third of people can still remember off the top of their head the names of all the people they went to school with. That's insane. Okay, so that's the last study on duration. Now, just to summarize, damn it, I've covered it up with my face, but in the bottom there, that's long-term memory is what my face is covering up. So you've got short-term and long-term memory. This is basically what we've just covered. Okay, this is everything we've just covered. It's a nice, easy, succinct little package. This what you should do if you're a student, if you're learning, is you should take all the information and you should condense it as small as possible. It's the best way to learn anything. Okay. This is the summary. You've got coding, capacity, and duration. So the coding of short-term and long-term memory, we looked at that at the start. We talked about acoustic and semantic. Capacity, we said was, sorry, I messed up there, between 5 and 9 items, which is 7 overall. And we didn't look at the capacity of long-term memory, but it's potentially unlimited. Okay, we didn't do a study for that, the capacity of long-term memory, but it's potentially unlimited. Okay, we don't know the limits of what we can store in our memory. Okay, and then duration, we looked at that. We looked at 2 studies. So one for short-term memory, Peterson and Peterson. We can see that it's up to 18 seconds with a trigram study. And then the duration in long-term memory, we said is we're going to say it's potentially unlimited, because with that yearbook study, still a third of people could free recall people from names of people from their yearbook. Okay, so it's potentially unlimited. We don't know the limits of the duration of memories. Okay, or you can say unlimited, you can say a lifetime, right? And that is, in summary, that's everything in this section of memory. So that's coding, capacity, and duration of memory. You have two different systems, short-term and long-term, and they both work differently. Thank you very much for watching. If you've got any questions at all, pop them in the comments, and hopefully you found this useful. Thank you very much for watching.